So hello students, today we are going to discuss another important questions, another solution of question number 12, describing motion around us. That solution series we have started. So what is the question? The question is telling that the velocity time graph from 0 to 120 second for a cyclist is shown in the figure 4.30. So what is given in this question? It is given there is a velocity time graph. Velocity time graph means along y-axis you can see along y-axis velocity is given and along x-axis time is given. So time range has been provided already that it is from 0 second to 120 second. So they have told shade the areas in different colors representing displacement of the cyclist. Now whenever we are going to shade the areas representing displacement, the most important thing what they are telling, displacement. Now you might be thinking, sir, how we can obtain displacement from here, sir? Because here along y-axis, sir, velocity is given, and along x-axis, sir, time is given. So how is it possible to obtain velocity time graph? From the velocity time graph, how is it possible to obtain displacement? So very easy things it is. The thing is, if you are drawing an xy graph, what you are drawing, an xy graph. Now in the xy graph, suppose you have drawn a curve. Now whenever you are drawing a curve and you are obtaining the area under the curve, what you are obtaining? Area under the curve. Always remember, area under the curve in xy graph is equal to the product of variables, the product of physical quantity in x-axis into y-axis. Sir, what you are telling? Couldn't understand. You might be thinking that, sir, what I am telling. Whenever you are drawing an xy graph, suppose I am telling you velocity time graph. What I am drawing? Velocity time graph. When I am drawing any velocity time graph and I'm just willing to obtain the area under that velocity time graph. Area under velocity time graph will represent what? It will represent velocity into time, that is displacement. So area under velocity time graph, always remember, area under velocity time graph will give you what? This will give you displacement. So from this area we have to obtain displacement. So first portion, two questions are there. While the cyclist is moving with constant velocity, that portion we have to shed, and when the velocity of the cyclist is decreasing, that portion we have to shed. So coming to the answer portion, see, so whenever we are coming to the answer portion, first you can see I have given some names. Here you can see the graph. Along x-axis you see 0 to 20, the triangular portion is there. You see, wait a minute, you see this 0 to 20, if time is along 0 to 20, velocity is along 0 to 3. So this is a triangle. Now then from 20 to 100 second, from 20 second to 100 second, in this time interval, velocity is constant, 3 only, 3 meter per second. You just observe the thing, see the thing. Whenever we are coming from 20 second to 100 second, in this time period, velocity is only 3 meter per second. Can you observe? Velocity is only how much? 3 meter per second. And one more thing, from 100 second to 120 second, in this time break, velocity is decreasing. See this portion. So first region, this region you can see that this rectangular region or this you see in this rectangular region, the time period is 20 to 100 second. In this time period 20 to 100 second, velocity is same, 3 meter per second, 3 meter per second, 3 meter per second all the time. So from 20 to 100 meter per second, velocity is only 3 meter per second. So this is the region This is the region bounded by AB, which represents that cyclist is moving with constant velocity. This is actually depicting that the cyclist is moving with constant velocity. Another question they are asking, the cyclist is moving with decreasing velocity. In this portion you can see whenever 100 to 120 second, this 100 to 120 second velocity is decreasing from 3 to 2. In this portion you see velocity is 3, and whenever 120 second we are going, the velocity is, you can see, 2. You just observe the graph carefully. During 100-second time, the velocity is how much? Velocity is 3. And at 120-second time, velocity is how much? Velocity is 2. That means in this time period, 100 second to 120 second, this graph represent the velocity is decreasing. The velocity is what? The velocity is decreasing. So this region of trapezium, this region bounded by the curve, is representing that velocity of the cyclist is decreasing. Now we have to calculate displacement also. In the question they are asking the displacement of the graph now. So what we need to calculate? We need to calculate displacement. See the question now. Now what they are asking in the question. Let us come into the question. Yes, here is the question. So we have to calculate displacement and average acceleration in 120 second. So let's coming back to this portion. Let's come back to the solution portion. Wait. So okay, now if I told you, if I want to obtain the displacement, we have to obtain the area under velocity time graph, because area under velocity time graph gives you displacement. Now if I want to obtain the area under velocity time graph, first we have to obtain the area of this triangle, then we have to obtain the area of this rectangle. First area of this triangle, then area of this rectangle, then area of this trapezium. If I am adding these three areas consecutively, we will get the displacement, that is area under velocity time graph we will get. If we will get this area, and this area, and if we will add this, we will get the total area, and total area will give you the area under velocity time graph, which is representing displacement. Okay, no problem. So first, for this triangle, you can see for this triangle, for triangle, what is the formula of area? Half into base into height. Half into base into height. Base, see, 0 to 20 second. 0 to 20 second, this is the base. Height, velocity, this velocity 0 to 3 meter per second, this is the height. So half into base is 20 second. 0 to 20 second, what is the time gap? 20 second. And 0 to 3 meter, what is the time, what is the velocity gap? 3 meter per second. So the base is 20 second and height is 3 meter per second. So if I obtain half into base into height, you will see half into 20 minus 0 into 3 meter. That means 30 meter is the area of this triangle. I have given the name OAP. And what is the area of this rectangle, sir? Rectangle, we know the formula is length into breadth. Length 20 to 100. What is the distance? 20 to 100. 20 to 100, this distance is 100 minus 20, that is 80. And breadth 0 to 3. 0 to 3 means what is the breadth? 3 meter. So length into breadth 3 into 80, that is 240 meter. And the remaining area of the trapezium. What is the formula of area of the trapezium? For trapezium we know the parallel sides are there. So half of sum of parallel sides. Sir, parallel sides, what is the value of this parallel side? This is 3. This is 3. This value of this parallel, this is 2. See, parallel sides means this is a trapezium, right? In this trapezium, this side is representing 3 and this side is representing 2. And the perpendicular distance is representing this 100 to 120 second. This 20 second time interval is representing the perpendicular distance. This is the perpendicular distance. And this is the parallel sides. Parallel sides, one is 3, another is 2, and this perpendicular distance is 20. Now what is the formula? Half into sum of parallel sides into height or perpendicular distance. So if I come to that solution again, wait a minute, you see, if I come to this portion, it is not clear here actually, wait a minute. See, you can see here, half into 3 plus 2 into 20, the sum of parallel sides, so half into 5 into 20, 50 meter. So total displacement is how much? Total area 240 plus 50 plus 30 meter, total area is 320. So total displacement will be 320 meter. Now displacement is obtained. Now average acceleration, they are asking. Average acceleration formula we know, change in velocity by change in time. So if I am going to that portion solution, let me come to that portion solution. So if I am coming to that portion solution, you can see here, wait a minute. Here is the solution. See, area is what? Change in velocity by change in time. So change in velocity means final velocity minus initial velocity divided by time. Final velocity 3 meter per second, initial velocity 2 meter per second. Now here the final velocity and initial velocity 3 meter per second, 2 meter per second, this portion I am wrong because it was stopping. So this is the final velocity. See here, it is stopping at 2. The curve is starting from 0. The car is starting from rest. You understand this portion very slowly. The car is starting from rest. So what is the initial velocity? 0. Then car speed increases to 3. Then car speed continues to 3 meter per second. Then car speed just stops at 2 meter per second. So what is the final speed? Final speed 2 meter per second. What is the initial speed? So initial speed 0 meter per second. And what is the time interval? 0 to 120. So change in velocity 2 minus 0, 2 meter per second, and change in time 120. So acceleration is 1 by 60 meter per second square. Thank you.